All right. Um, Today's meeting, we will talk about the practice final exam. Before we start, I just want to remind you, don't forget to do the online evaluation. Okay, the evaluation is available now. Please do the online evaluation. Okay, um, let's start our practice final exam. Okay, the first question is about use the regular frequency table or frequency distribution to construct a cumulative frequency distribution. So although we do not mention cumulative frequency distribution in our class, we should know the cumulative frequency table is just a variation of the regular frequency table. So let's check this. This is the regular frequency table, right? We're going to use this one to construct corresponding cumulative one. So cumulative, we will still have two columns. We will still have two columns. But the first column, we do not have the upper limit, lower limit. We do not have the upper limit, lower limit. For example, the first one, original frequency table is a range, right? 1.0 to 1.5. We're going to change this one to less than something. So if it's 1.0 to 1.5, we're going to change it to less than 1.6. Make sure you know it's not less than 1.5. It should be less than 1.6 because the second one is from 1.6. So the first one should be less than 1.6. Similarly, the second one will be less than 2.2 because the third one is start from 2.2. So the second category should be less than 2.2 and so on. Less than 2.6, 2.8, less than 3.4. And the last one will be less than 4.0. Okay, last one will be 4.0. You see, each one has the same difference. 1.6 plus 0.6 to get 2.2 plus 0.6 to get 2.8. Okay, and another column because we are constructing the cumulative frequency. So the first frequency is still the same as the original table. It's still 3. But from the second one, we should get the cumulative frequency, which means the frequency is cumulative. So the second one, we should, how can we get 9? We add 6 to 3 to get the cumulative of the second class. So we will get 9. Then we get 9 for the second class less than 2.2. We add the third one, 5, which also means we add 3, 6, and 5 together to get 14. Similarly, we add another 4 to get 18 and add the last 2 to get the last one. So it's just cumulative. Okay, so that's how we use the original frequency table to construct the corresponding cumulative distribution. So this is the first one. Let's check the second question. The second question just want to find the median. Find the median. We have a group of numbers and we just want to find the median. How can we find the median? Remember, median is which one just in the middle, right? So how can we find the median? First, we need to sort our data. We need to sort our data from the least to the greatest. So first step, we're going to sort our data. And after we sort our data, we realize we have 10 values in total. 10 is an even number, right? 10 is an even number. We have 1, 2, 3, 4, 5, 10 values. 10 is an even number. Remember, how can we get to the median if we have even number values? Because we will find two values right in the middle. If that's an odd number, we will find exactly one value right in the middle. Then that one is our median. But for even number values, we will find the two values right in the middle. Then median will be the mean value of these two values. So after we check our sorted data, we realize this time we have these two values right in the middle, right? So we only need to find the mean of these two values. So we add them up divided by 2 to get the mean. So for this question, 8.5 is the median. It's just the median, okay? If you want to find the median, you need to sort your data first and find which one value or which two values right in the middle. So let's check the third one. This time we want to find the mean value. Find the mean value for your data, okay? So mean value is just add them up to find the sum. So this is how we get the sum, right? We want to add all the values together. Then we know we have 6 values in total. So we need to divide the sum by 6. Divided the 6. That's how many values do we have? That's our n, right? That's our n. And the top will be the sigma x, which means each value we should use. Then we add them up to find the sum. So remember, the notation of sample mean is x bar. Okay, is x bar. That's our sample mean. So the answer here will be 9.885. 9.885. You can check your answers to see if it's correct. Okay, of course, you could use your calculator. Now let's check the next one, number 4. Number 4. Okay, number 4. We want to use the z-score. So first of all, we need to find what is the z-score. We have the value. We need to find the z-score. Then we're going to use the z-score to determine the value is unusual or usual. Right? And that one is an explanation of what is called unusual. If the z-score is less than -2 or greater than 2, which means the absolute value is greater than 2, right? So this kind of z-score, we will say the value is unusual. Okay, let's see. This time we have the value is 84 points, which means that's our x value, right? This is our x value. This is the value we're gonna test if this 184 is usual or unusual. And if we want to get the z-score, we still need to know some value. The first one is what's the mean? So that's the x bar. So we should have a mean. And we also need to know the standard deviation. We also need to know the standard deviation, right? So, oh, okay. We have here, we have among a population have a mean. So here, the mean is the population mean. We're going to use the notation mu to represent the population. Okay, here it says the population. Of course, the standard deviation, we're going to use sigma. Okay, we're going to use sigma. Let's check how can we do this problem. So first step, we're going to find what is our z-score? Remember, we use mu here because it's about the population. And if it's from population, we're going to use sigma to represent the standard deviation. And the first value, don't forget, it's always the x value. It's the x value, okay? X value here is the value 884. Then minus our mean value, 74. Again, x value goes first. Then we have the mean value divided by the standard deviation. In this case, standard deviation is 3.4. So we will get the z-score 2.94. This is the first part of the question, right? We're gonna find the z-score. Remember, we have the second part of the question. We're gonna use the z-score to determine if that value, 84, the x value, is usual or unusual. Remember, what is the rule? If it's greater than 2 or less than -2, which means we know the absolute value should be greater than 2. So here we know 2.94 is greater than 2. So we know it is unusual. It is unusual. Okay, so first you're gonna use the formula. Make sure you understand what is x, what is mu. Get the correct z-score. After that, you should use this value to compare to 2 or -2. Okay, if it's greater than 2 or less than -2, which means the absolute value of your z is greater than 2, we're gonna know that value is unusual. Okay, so that's for question number 4. Let's check the next one. The next one is about find the third quartile, the Q3. I don't know if you still remember, how can we get to the quartiles? We could not directly get the value of quartile. We're going to use the percentile to get the quartile. So first step, don't forget, we need to sort our data. So we need to sort our data. So let's see, the first step, we're gonna sort our data. Sort our data from the smallest to the greatest, right? So after that, we also know if we want to know Q3, we actually want to get what is the P75. We actually want to find the P75. Q1 is just P25. Q2 is just the P50, which is also called median. Q3 is P75. So we're going to use the formula to find which value is our Q3. So this is the formula. This is the formula, right? Because we want to find 75 quartiles. So here, this value is the K value. This subscript is our K value, 75. So we put 75 over 100, then times n. N means how many values do we have in total? So here, in this case, we have 8 values, 8 numbers. So we times 8. And we will get L is equal to 6. So remember, we have 2 different situations. If we got a whole number for L, we need to check 2 values. So if L is 6, here is a whole number, we're gonna check which one is the 6th value from the smallest to the greatest. 6. And we need to check which one is the next one, which means we need to check 2 values, 6 and the 7th. If L is a whole number, okay? Whole number, we're gonna check 2. 6 and the 7th. Which one is the Q3 or P75? We're going to say the mean value of this true value is just the Q3. So here we will check two values since L is a whole number. So we check 6 and 7th, and the mean of these two values is our Q3. So here is 161. 161. Okay, but you still remember if L is not a whole number, let's say if L is just like 6.2, it's a decimal, it's not a whole number, then we're gonna just check one value. We always round up to next whole number. So if it's 6.2, we will still round up to 7. We only need to check one value. 7th value will be our Q3. Okay, you should be very careful. If L is a whole number, you need to check 2. Okay, so this is the Q3 problem. Next problem we will talk about. Two dice are rolled. What is the probability that the sum of the two numbers on the device will be 6? So this is a probability problem. This is a classical probability problem. Let's check. This time we have two dice, right? We have two dice, and we only focus on the sum of these two dice. So first, let's check if we have die 1 and the die 2, how many possible outcomes do we have? So for the first die, we have number 1 to 6. So there will be 6 possible numbers, right? And for die 2, we still have number 1 from number 2. We still have 6 different. And our event is die 1 and die 2. We should roll 2 dice. So we should use the multiplication rule of the probability, or the multiplication rule of combination. Counting, I mean. The multiplication rule of counting. So 6 different way times 6 different way, different number. So total possible outcome is 36. Okay. Now we're going to list how many cases we will get the sum. 6. So let's check. The first one is if die 1 is 1 and the die 2 is 5. Second one, we will have 2 and 4. But we just have 3, 3, because if we change, it's still 3, 3. But for the next one will be the 4, 2. 2, 4, 4, 2. It's not the same, right? Because the order changes. Die 1, die 2. So 2, 4, 4, 2. And the last one will be 5, 1. Die 1 gets 5, and the die 2 gets 1. So total, we will have 5 cases. 5 cases. The sum of two numbers equals 6. We have 5 cases. So the probability will be 5 cases. We get 6, and the sum 6, and over total outcome 36. So the probability will be 5 over 36. Now let's check the next one. Number 7. So this is the probability distribution. Okay, we want to find the mean, because we have the probability distribution. This information gives you the probability distribution. So you could use the information to list the probability distribution. List that table first. Then you're going to use the formula to solve this problem. So number 7. Let's check this one. First, we're going to use the information to list our table. This is the probability distribution, okay? Probability distribution, do you still remember? We have one column called X value, the different value for this variable X. Then another column is called probability. So that's why we call it probability distribution. So for each X value, we have a probability. So from the original question, it says the X value is 0, 1, 2, right? And we also have the corresponding probability 0.5, 0.42, 0.08. So that's how we list the table. X, 0, 1, 2, and corresponding probability is here. Now, from this question, we know we want to find the mean value. So you're going to use the mean value for the probability. Okay, you're going to use a mean value. So it will be sigma x times px. So first, we're going to find the product for each x and its corresponding probability. After that, after we get the probability, the product, we want to find the sum. So for example, we have the first value 0 for x. So the first one, x times px, will be 0 times 0.5. So I list 0 times 0.5 will be our first term, right? And the second product will be 1 times 0.42. That's our second product. And the last one will be 2 times 0.08. But don't forget, after we get the product, we need to find the sum of all the products. So I add them together. So this 0.58 is the mean from our probability distribution. Okay. Now let's check the number 8. Let's check number 8. So this time, we're going to talk about the binomial distribution. Binomial distribution. And the question already lists the number you're going to need. So n, how many trials do we have? N is equal to 8. And x is equal to 3, which means 3 successes. X is the number of successes. And the lowercase p, which means the probability of one success. Probability of one success. Okay, so remember, we only need to use the formula to find the probability of x successes, which means 3 successes in this case. So we're going to use the binomial distribution formula. So x is equal to 3. So this is the corresponding binomial formula, right? And we have 8. And we know we have 3 successes. 8 minus 3, which means 5 failures. And this is the probability of success. And this is the number, make sure. Here is the p, then the corresponding power will be just the number of successes. And this 0.7 is the probability of a failure, right? So here is failure, then here 5 is the number of failure. So after we plug it into the formula, we will get 0.254 is the probability, the are interested in. The probability, we got exactly 3 successes. The probability, we got 3 successes. Okay. So next one, we talk about the probability by using the Z, which means we're going to use the Z table. We're going to use the Z table. Okay, so let's check. We have 2 Z values. So we can say Z1 is negative 0.75. Z2 can be the positive 0.75. How can we find the probability? We're going to use Z table. Find the area, right? Area between these 2 Z's. That will be our probability. So let's check. How can we get it? How can we get it? So we list 2 Z's. We know we should use the table, right? The area is just the probability. So let's go to check the Z table. So for first Z, we're gonna find one corresponding area. Okay, one Z, we will have one area. So from the table, so by this time, you should be very familiar with how to use the Z table to check the corresponding area, right? By using the Z table. So this time we have a negative Z, which means we should check the negative Z table. We will find this is the corresponding 0.2266. So this is the first area. Of course, we have second Z. We also need to check the Z table. This time it's a positive value. So we're going to check the positive Z table. We find this one, 0.7734. So first step, we use the Z value to get the area. Next step, what is the probability between these 2 Z's? That's the area between 2 Z's, which means we need to find the difference of these 2 areas. Difference between these 2 areas, okay? So here, we're gonna say the probability between these 2 Z's, Z between these 2 values is just the difference of 2 areas. See, we find the area, then find the difference. Some students do like this one. First, find the difference between 2 Z's. Okay, we find it's 1.5. The difference is 1.5. They use that 1.5 to find to check the Z table to find the area. It's totally wrong, okay? You need to check each Z for an area. 2 Z's, 2 area. Then find the difference between 2 areas. That's the probability. So next one, we will still talk about the Z-score. We will still talk about the Z-score. So this time we have the heights of the man. Okay, we have the heights of the man we're talking about. And we know the population. The heights of the men are normally distributed. And we know the mean value. So here it's from the population. The population is also normally distributed. And we also know that the standard deviation, sigma, is also from the population, right? So we're gonna find the probability. A random selected man is more than. So first, we should be very careful. Here is more than, which means it's greater than, right? We're going to use this sign, greater than. Greater than, and then we have the value here is 70.6. 70.6. That's why we should say you should be careful about more than. Remember, it goes right. More than means it's the area cumulative to the right. So you should be careful. We're gonna use the cumulative area from the right to represent the probability greater than 70.6. How can we do the first step? We're still gonna use the Z to find the area. So the first step, we're gonna find the Z-score. We're gonna find the Z-score. So in this case, again, the value we're gonna test here is 70.6. So that will be our X value, right? That will be our X value. So X value goes first. The value we're gonna test always goes first. So 70.6. Next one, we should minus our mean value. So mean value here is 68.6. So don't mess up the order. Okay, this one is the first value because we're gonna test this value. And this is the mean value divided by the standard deviation, 2.8. The denominator is 2.8. Some students put the mean value as the denominator. Okay, make sure you know that's the standard deviation. After that, we got our Z value. Z value is 0.714. So this is not the area, right? This is just the standardized score, Z-score. We're gonna use this Z to check the table, which means we're gonna check the positive Z table, right? We're gonna check the positive Z table. So we have the area directly from our Z table for this Z-score. We have the area is 0.7611. This value is directly from your Z table. Again, we use this Z, 0.71. Actually, we only need to keep 2 decimal places, right? Because in our Z-score, we only have 2 decimal places for Z. So 0.71, we have this area, 0.7611. That's just like I said, our problem is more than. So this area is not the area cumulative from the right side. It's just the area from the right, left side. So don't forget, you still need to do one more step. Because the area directly from the table is not the area cumulative to the right. So we need to use total area minus the area cumulative to the left to get the area cumulative from right. This one will be the answer. Okay, this one will be the answer because X is greater than 70.6. If here X is less than 70.6, if it's the less than 70.6, then the value 0.7611 will be automatic the answer. Okay, will be automatic the answer. But this time we got greater than. Don't forget you need to do one more step. Okay, now we check next one, number 11. Number 11. Number 11 is about the confidence interval. It's just the confidence interval. So we have the n value. Okay, we have the n value. It tells you n is 100. And we also know the x value. And we also have the confidence level, 95%. Okay, we only need to construct a confidence interval for the proportion. We want to construct the confidence interval for P. So remember, how can we construct the confidence interval for P? First, we gonna find what's the P hat. Remember, the confidence interval for P follows this format. Point estimate plus minus margin of error. So first step, we gonna get the P hat. So sometimes we can directly find that sample proportion in our question. The question will give you that value, P hat, sample proportion, right? But in this case, we do not have that value, P hat. But we could still use N value and X value to get the P hat. So let's check how can we get P hat. So first step, we're gonna find the P hat. P hat is just X divided by N. X divided by N. So how many successes? So 90 out of 100. 90 successes. 90 people respond with yes. So 90 divided by 100. 100, that's total number we have. X divided by N. So this is the sample proportion P hat. It's also the best point estimate. Next step, we're gonna find the margin of error, right? Because the format is P hat plus minus E, margin of error. But before we get the margin of error, we know we need to check what's the critical value, Z sub half alpha. But the question did not directly give you the alpha value. But question tells you the confidence level. Confidence level is 95%. So I hope you still remember the relationship between the alpha and the confidence level. 1 minus alpha is the confidence level. Then alpha is 1 minus confidence level. So here, alpha is 1 minus 95%. We get a 5%, which is 0.05. But we do not directly use the alpha value to check the critical value. We actually need to use the half alpha value. So don't forget, divided by 2 to get 0.025 to get half alpha value. So next step, we're gonna find Z sub half alpha. Z sub half alpha is Z sub 0.025. So you should know how to use this subscript to find the corresponding critical value. Okay, this one 0.025 means the area cumulative from the right of this Z is just 0.025. Okay, just a quick reminder. This Z sub 0.025 means the area to the right, this part is 0.025. Okay, how can we get that value? We could not directly use 0.025 to check the table because this is the area from right. We're gonna use the area from left. So that will be the blank part, 975. This is the total area minus the right side to get the left side, 0.975. Then we check the body of our C table. Body is just the area. So we find which one is similar, the most close to this one, or just the exactly number. So this time, if you check your table, you will find the exactly same value as the 0.975. Then you check the margin to find the Z-score. So if you're already very familiar with this critical value, you will realize this is the most common one. 1.96. 1.96 is just z sub 0.025. So next step, just plug it into the formula. Okay, so we know p hat is just 0.9. Of course, q hat is always 1 minus p hat. So we know it's 0.1 divided by the total number. After that, you will get the margin of error. Okay, you get the point estimate, you have the margin of error. So next step, we're gonna write our confidence interval into the correct formula. Point estimate plus minus margin of error. So here, 0.9 plus minus 0.0588. So keep 3 significant numbers, significant digits. So our confidence interval will be this one, or this one. Okay, that's for the number 11. Okay, so next one will be number 12. It's still about the confidence interval. Confidence interval. So it's almost the same step as the previous one. Almost the same step. But this time the confidence level is 90 degrees. So you still remember how can we do it? First, we're gonna use the information to get to the p hat value. So here, from the original question, we know 201 adults select random from one town. So that's the total number we have, right? 201 adult. And 179 have credit card, which means 175 is the number of X. This adult responds with yes, they have credit card. So this is the X value we have, 179. Total number is 201. So we're going to use this one p hat to get to the p hat. X divided by n. We will have this 0.89. 89. So the same step, first p hat. Now we're gonna find what's the alpha, then half alpha value. After that, we're gonna check the z sub half alpha. That's the critical value. So here we know the confidence level is 90%, which means the alpha is 1 minus 90%, is 0.1. Then don't forget, we should use the half alpha. So half alpha here is 0.05. Then we're gonna use the same way to check z sub half alpha. Here is z sub 0.05. So this one is another common critical value. Maybe you could pick 0.64. Sometimes some students pick 1.65. So here we just pick the value in the middle of this two. It's 1.645. Okay, that's another common critical value. Z sub 0.05. So this time we still need to plug it into the formula. So p hat 0.89. Q hat will be 1 minus p hat, right? We will get 0.11 and divided by total number. Take the square root. After that, we will get the margin of error. So last step, we're gonna write it into the correct formula. P hat plus minus margin of error. So keep 3 significant digits. Keep 3 significant digits. That's our confidence interval. So next one. Number 13. It's still about the confidence interval, but this time we gonna find the confidence interval for the mean, for the mu. So this is another confidence interval, but it's still follow the same step. First, we're gonna find the point estimate. First, we're gonna find the point estimate. Remember, when we talk about confidence interval for proportion, confidence interval for mean value, these two kinds of confidence interval always follow the same format. The point estimate plus minus the margin of error. Point estimate plus minus the margin of error. But when we talk about the confidence interval for the standard deviation, sigma, or the confidence interval for the sigma square variance, we do not follow that format, right? It's not the same thing. So this one is the confidence interval for mu. So it's still point estimate plus minus margin of error. And from the original question, we know we only have the standard deviation 3.2, and we need to figure out this standard deviation is from our sample or from the population. So here we know this one, the standard deviation is from the group of 66 selected students, which means this standard deviation is the sample standard deviation. If we just have the sample standard deviation, so here we cannot know any information about the population standard deviation. So here we only know S. Sigma is unknown. Why we should tell you sigma is unknown for this case? Because we know if sigma is unknown, we're going to choose T distribution, right? We're going to choose T distribution. But if sigma is known, we're going to choose Z distribution. So that's the big difference. Okay, so we list all the information we have. And we realize here the standard deviation is sample, is from the sample. So we're gonna use S to represent this standard deviation. And we know sigma is unknown for this case. So we're gonna check the T table for the critical value. Okay, so first we know this X bar is the mean value, is the sample mean, so that's the point estimate, right? So we only need to figure out what is the margin of error E. So this is the correct formula for the margin of error when we do the confidence interval for mean value. So you see, for the proportion and for the mean, we have totally different formula to get the margin of error. So don't mess up. This is the formula for the confidence interval of mean value. And the previous margin of error is the formula for the proportion, okay? So here, we're gonna check the T table to find the critical value. So when we check the T table, we're gonna use the half alpha value. And we also need to check the degrees of freedom. Degrees of freedom. So here, we will still find what is the alpha value first. Alpha value is 0.1, and divided by 2 half alpha, we will get 0.05. Don't forget, you also need the degrees of freedom, which is the n minus 1. So 65 is in this case. We check the T table. If you forget how to check the T table, you could find the short video in the content. I think I already posted 3 short videos to tell you how to check the Z table, how to check the T table, and how to check the chi-square table. If you already forget it, you can go to check it, okay, in the content. All right, so in your T table, we're gonna find this critical value and plug into other values. We will get the margin of error. Okay, we will have the module. So next step, we're gonna write our confidence interval into the correct format. So point estimate, X bar. We already get the X bar directly from the question, right? X bar plus minus module. So here, this is the final answer. This is the final answer, okay? So let's talk about the next one. Number 14. This time we're going to talk about the hypothesis test. So when we talk about hypothesis test, remember, first step, we're going to have a claim. We need to figure out which sentence is our statement, is our claim, or our assumption. So this is our assumption. .7% said they use at least one prescription. So we have the proportion in our assumption, right? 81.7%. We have a percentile, we have a proportion in our assumption, which means we're gonna do the hypothesis test of proportion. So we need to find the test statistic Z. This test statistic Z is about the test of the proportion. So let's list the information first. Okay, this is the, sorry, I made a mistake. So this is not the claim. This is the sample statistic. So here, this one will be from the sample. So this is from the sample. This is our sample. 3,005 subjects. Okay, this is 3,005 subjects. So here, this value is not a claim. We have the claim actually is this one. The claim said more than 0.8. More than 0.8. So this more than 0.8 is our claim. More than 80% of the people used at least one prescription. Age from 57 to 85. So we have a claim. This is the correct claim, more than 80% or more than 0.8. So here we still have the proportion in our claim. We're gonna do the test about the proportion. So here, again, I made a mistake. This value is the p-hat. This is the value from our sample. Okay, this is the value from our sample. This is p-hat value. So we list the p-hat value here. And we also know this is the value in the claim. The claim said p is greater than 0.8. Greater than 0.8. So that's the 0.8 is the value in the claim. The claim said more than 0.8. So this is the value in the claim. This will be our P. Okay, the value in our claim is the value of P. And the value from our sample is the value of p-hat. So you could always find the p-value from your claim. So we're gonna use this formula to find the test statistic. So here, this is the correct formula to find the test statistics Z when we do the test of proportion. Again, the first term is P hat. So the first value is from your sample. Okay. The second value, P, is your population proportion. How can we find the population proportion, P? We always check the claim. Check the claim or check your hypothesis. Okay. So here is just 0.8. So after that, we will get the test statistics Z 2.33. Make sure you pick the correct formula. So next one will be number 15. Number 15, we want to list the non-technical conclusion. Non-technical conclusion. Non-technical conclusion. Because we already know the technical conclusion is reject our none. So our technical conclusion is reject none. We want to state the non-technical conclusion. Let's check what is the hypothesis we have. Then we could know what does that mean, reject none. Okay, so we have a claim. The mean evaluation better than 3.7. So the evaluation has a mean better than 3.7. So this is the claim about the mean value, which means this test is about the mean value, right? So we're gonna use the mu to represent mean. And we will list the hypothesis like this. We will list the hypothesis like this. Our none is mu equals 3.7. And another alternative will be mu greater than 3.7. Why we will have this as our none and alternative? Because our original one is better than 3.7. Greater than 3.7, right? And we also know it's about the mean, so we will say it's mu greater than 3.7. So we list mu greater 0.7 first. After that, we should determine this one is our none or alternative. And we realize the sign in the middle is just a greater than sign. It's not an equal sign, so this one can only be our alternative. Right? It can only be our alternative. And we could list the none. We only need to change the sign to the equal sign. So that one will be our non-hypothesis. So by this step, we have our none and alternative. And we already know the conclusion is reject none. So we will say we rejected it, right? So it means we will take this. So this is our non-technical conclusion. There is sufficient evidence to support the claim. Which claim we're going to take? The mean is better than 3.7. We rejected this. We're going to accept this. We're going to take this, right? So there is sufficient evidence to support the claim. Which claim? This claim. The mean of the evaluation is better than 3.7. Okay. So you need to list what is your none and what is your alternative. After that, you could see your technical conclusion is reject none or do not reject none, fail to reject none. So in this case, we reject none, so we will take this alternative. Now we will move to number 16. So today's video is is long, I will say, because I try to finish all of the questions of our practice final exam. Because you have enough time to review all of the questions, right? But before you review my solution, make sure you could do all the problems by yourself. Before review my solution, make sure you can do it by yourself. After that, you review my solution, okay? And I hope you can do this practice final exam at least 3 times. At least 3 times, because this one is extremely similar to your final exam. I just check the background, check the number, but all the topics will be exactly the same. Okay, let's check next one, number 16. Number 16. So this time we're gonna talk about, we will use normal distribution to approximate the binomial distribution. We're gonna use the normal distribution to approximate the binomial. So we're gonna use a continuous distribution to estimate a discrete. So when we talk about this kind of case, make sure you know we should do the continuity correction, right? So this time, we could not directly use this at least 219. At least if we translate it into expression will be greater than and equal to. Greater than and equal to, or equal to, right? Greater than or equal to. So it's possible to get exactly 219. So from the original sentence, we have greater than or equal to 219. But we still cannot directly use this value 219. Just like I said, we use a continuous distribution to approximate the discrete distribution. We should do the correction called the continuity correction. If you still remember it, after the correction, we will get x is greater than 218.5. So first, we translate at least 219 to x is greater than or equal to 219, right? We only do the translation. After that, we will do the correction. We will get this value, x greater than 218.5. Remember, how can we do the correction? We plus 0.5 or minus 0.5. But we should pick which one for this case. It depends on this single value is included or excluded, right? Here we know the original x is possible to be exactly 219. So if we will have two choices, right? We will have this two choice because the correction is plus 0.5 minus 0.5. So plus 0.5, we got the 219.5. Minus 0.5, we'll get 218.5. But which one is the correct value? We just work on the single value 219. We know from the original range, x can be included. So which means x is a possible value here. We have the equal sign, right? X can be exactly 219. If we pick this one, let's check. 219 is excluded in this range, right? It's greater than 219.5. Then 219 is not possible value, not a possible value here. So which means it's not correct. But when we check this one, x is greater than 218.5, then we think it's still possible to get 219. So this 218.5 is the correct value after the correction. So here we pick 218.5. Next step, we're gonna use the binomial to get the value we need to find the z. Okay, we need to check the z, then use that z to check the table to find the area. But we need to have the mu value, the sigma value to get the z, right? So we're going to use the binomial formula to get this value. We're going to use the binomial now to get the mu. So this is the formula for binomial distribution. Mu is equal to NP. Okay, so how can we get in? We go back to the problem. We know we have 10,000 randomly selected dryers, right? So here we have the n value, 10,000. And we also need to know the p-value, right? P-value. So here, 2% of the higher dryer are defective. So this is the p-value, lowercase p. Lowercase p, okay? So we use this formula. 10,000 times 2%, 0.02. We will get the mu, and similarly, we will use this formula for binomial to get the sigma. After that, we will get the z-score, okay? We're gonna use the z-score to check the area. So first, what is the z-score? We will use the formula. First, the x value. So here, again, the x value is no longer 219. No longer 219. You should use the value after the correction. The new x1 will be 218.5. So that is the x here, 218.5 minus this is the mu, right? So from the previous one, we know that's 200. And divided by the 14, that's the sigma. So we will get the z, 1.32. 1.32. Then we're going to check this z in our z table. We will get the number, the area is 0.9066. But we should ask ourselves the question, is that the final answer we are interested? Is that the probability we want to get? Because this is the area cumulative from left. It's directly from the table, right? But we go back to check the claim. We actually talking about the probability of x is greater than some value. So if it's more than some value, greater than some value, actually we are talking about the area cumulative from the right. So the area cumulative from the left is not the final answer. We're gonna do one more step. Total area minus the area from the left, and we get the area to the right. So that one will be the final answer of our question. That will be the final answer. Okay, so the whole question has several steps. So first, you're gonna find the new x value after you do the correction. So the first step, we're gonna find the new x value. We translate this one to be this one. And if you forget how to do the correction, you can check the table. You will have the whole table to tell you how to do the correction. Okay, in your textbook. Then we're going to use the binomial formula to get what's the mu and what's the sigma. Why we need to get these two values? Because we're going to use these two values to get the z, to get the z-score. After we get the z-score, we check the table to find the area. But last step, we should go back to check if this area is our final answer. But this time we know we actually want to get the area to the right. So don't forget, you still need to do the last step. Okay, so that's for number 16. So next one, number 17, we're gonna find the probability. If we are talking the probability, the first thing you're gonna realize is maybe we need to check the table, right? We're gonna check the z table to find the probability. So here we have two values. So this will be our first x value. This will be our second x value. We want to test the area or the probability between two values, two x values, which means we are actually talking about the area between two values. Between two values. We are talking about area between two values. So we need to transfer our x value to z value first. Then we could find the area between two z, right? So first, we're gonna switch our x to our z. So I list the information we have here, the mean value and the sigma value. It's directly from the question, the mean and the standard deviation. So first x is 1,100. So we're gonna use this formula C. Again, the first is the x value. We're gonna test minus the mean value. So we will have this Z. Similarly, we will do the second one, x2. Do the same thing to get z2. Okay. After that, we're going to check the z table. Again, we need to get the difference between two areas. Do not plus minus your z to get the difference or something else. We do not do any operation on our z's. We have z just to, we can use the z to determine the value is usual or unusual. We could use the z to find the corresponding area, but we never direct do any operation on z. Okay, so we use z to check the table to find one area and another area for another z. After that, we need to find the difference of two areas. Again, don't use 0.8 minus 0.23. Then you have that one to check the table. That's totally wrong. That's a common mistake. Again, Z1 to find one area, Z2 to find another area. After that, find the difference of these two areas. That one is the probability we want to get. Next one. Okay, that one is about number 18. That one is about still about the Z. But this one is a little bit different from part A to part B. Let's check the question. First, we could list the information we have. We have the mean value and the standard deviation. Let's check part A first. if one single student is randomly selected. So we want to find the probability. The score is above, so here is greater than 500, right? So make sure you know the area should be from the right side, So make sure, don't forget this one. Let's check part A first. Let's check part A. So we know single student select. So we have X value. We only have one single student. So we know X is equal to 500, right? We transfer this single X value to the Z-score. So here we know 500 is the single X value because we only randomly picked one student. That's the single X value minus the mu value. Mu is from your question, right? And divided by the sigma. So we have the Z. We transfer our single X value to the Z. And we use this Z. This is the Z. This is not the area, okay? Also, if one looks like an area, it's just the Z-score. We still need to check the Z to find the area. This is, again, the area to the left. Remember when we say the question is more than something, right? At least or greater than something, it's the area to the right. So don't forget this step. Total area minus the area to the left, we will get the area from the right. So we finished the first part, part A. We know we have single X value, so we need to transfer the single X value to the Z-score and find the corresponding area. Make sure we know if that's the area we want or we need to do the last step. Now we check the second question. This time, we need to randomly select 35 students. And we're gonna find the probability. First question, we talk about the probability of that score. So that's the single score. But this time we want to find the probability, the mean score. So if here, you know, we are actually talking about the mean score because we have 35 students. So it's not a single value, it's a mean value. It's not a single X value, it's the mean. So it's the X bar above 500. So this one is X bar greater than. The first one is X greater than 500. Second one is X bar greater than 500. So this one is extremely important. Why we will say it's extremely important? Because if we are talking about the mean value of X, we have a totally different formula for the Z-score. Remember, that's called central limit theorem. So actually this part B is about the central limit theorem. We're gonna use the different Z formula. And in the central limit theorem formula, you will realize the first value is not the single X value. It should be the X bar. And for this one, X bar value is 500. This 500 is the X bar value, the mean value. Then we still need to divide it by the mu, the population mean. But make sure the big difference is the denominator. Denominator have the square root of n. Have the square root of n. The original one, we just use the sigma as our denominator. But for the central limit series Z formula, we also have the square root of n term. So after that, we get the Z-score. Then the remaining part is just the same. Use the Z to check the table to find the area. But we should still know this is not the final answer because this one is still the area to the left. We still interested in the area to the right, so don't forget the last step. total area minus the area from the left to get the area from the right. But this part B, you should be very careful because this is the central limit theory. Because we are talking about the x bar, okay? So make sure you understand that the denominator should have the square root of n term. All right, let's check next one. Number 19. Oh, sorry. We still have part C. Part C for the question. The question says these two will be very similar. Part C. Part A and part B are very similar. Which question requires the application of the central limit theorem? So I've already answered this question. Part B, right? Part B. So next one will be number 19. Number 19. Number 19 is still about the confidence interval of proportion. So which means the confidence interval is very important in our final exam, right? So number 19, we have this. This will be the total number we have. That's the n value. How many students we randomly selected. And the 21 response with yes. So that's the x value we have. And we still need to know the best point estimate, which is the p-hat, right? And part B, we're going to find the confidence interval for the proportion. Confidence interval for the proportion. So let's check. How can we find the best point estimate? We already know we could use this formula. The n divided by the x, right? So the part one is very simple. We only need to use n divided by x. That's how we get the p-hat value. Part B, we always do the same thing as previous two questions, two previous confidence interval questions. We find the alpha value. Don't forget, we're talking about the half alpha value. And I hope you can memorize this important critical value, C sub 0.025. So it's 1.96. And plug into the formula to get what is your margin of error. Margin of error. So last step, we just use this one. Confidence interval, p-hat plus minus margin of error. So point estimate from the part A and margin of error from part B, we could get that's the final confidence interval for P. So we already finished 3 problems about confidence interval of the proportion. So which means the confidence interval is very, very important. Now, next one, we will talk about another confidence interval. Okay, we will talk about another confidence interval. So number 20, we could check the problem. We could check the problem. We have the mean value, and we also know the S. So here, the S means it's the sample standard deviation, right? It's the sample standard deviation. So we will say if we only know the sample standard deviation, which means the sigma is unknown. Why I should write sigma is unknown here? Because I want to remind myself we're gonna use the T distribution, right? We're gonna check the T table for the critical value. So let's see. How can we solve this problem? Part A, we're gonna find the critical value. We're gonna find the critical value. So first, we know we only have the S value, which means sigma is unknown. So we're gonna use T table to check the critical value. When we check the T table, we still need to know the half alpha value, and we also need to know what's the degrees of freedom. So here, we use the confidence level to get the alpha value first, then divided by 2 to get the half alpha value. And we use n minus 1 to find the degrees freedom. After that, check the T table. Again, if you already forget how to check the Z table, T table, chi-square table, make sure you could check the content for 3 short videos. I posted the videos to show you how to check the tables. After we have the critical value for the first part, right? The second part, part B, we're gonna construct the confidence interval. Of course, when we talk about the confidence interval, we need to know the margin of error. Margin of error here, because here we're gonna check the T table. So remember, the formula is T as our critical value. So this is the margin of error. This is the margin of error, okay? So next step, we only need to put the point estimate plus minus margin of error to construct the confidence interval for mu. So this is the final answer, the final answer. So next question. So we already have 2 questions about confidence interval of the mean, 3 questions about confidence interval of the proportion. We have another confidence interval, remember? The confidence interval of standard deviation. So number 21 is about confidence interval of the standard deviation, sigma 21. So before we start this one, you should memorize for the confidence interval of the standard deviation or variance, we do not format the point estimate plus minus the margin of error. This one is a special one, right? We need to check 2 critical values. We need to check 2 critical values. Why we need to check 2 critical values? Because the curve is not symmetric for the chi-square table, for the chi-square distribution. The curve is not symmetric. So we need to check both sides for the critical value. Let's check the question. So we still need to know the half alpha value. So I will start with the right side critical value because we're going to use the value of half alpha to check the right side critical value. And we're going to use 1 minus half alpha value to get to the left side critical value. Again, you need to find the critical value for both left side and the right side. But for the right side, we use the half alpha value. Right, left side, you use 1 minus half alpha. Again, you could always find how to check the chi-square table in your content. There is also a short video to show you how to check the chi-square table. Okay, after that, we only need to plug into the formula. See, the right critical value actually goes to the left side. So the left side actually goes to the right. So use the correct formula, plug into the numbers. Oh, again, when we talk about the chi-square table, we also need to use the degrees of freedom. The degrees of freedom is 2 and minus 1. Okay, so This is how we use the correct formula. Again, this one does not follow the point estimate plus minus module of n. It's not. It is not correct. Okay, it's wrong. This one is the special one. Okay, next, number 22. You want to estimate the sample size. The sample size. Number 22, we're talking about the sample size. So for the sample size, we only need to use the correct formula, then plug it into the formula, we could get it. So we just list. And when we talk about the sample size, we always use the Z as our critical value. No matter it's about the proportion or the mean value, we always gonna use the Z as our critical value. Because remember, in this formula, we have the sigma. Even we do not know the actually value of the sigma, we will use the S value to estimate the sigma. We're gonna still use the Z as our critical value. That's for the sample size. Okay, so from the question, we know we should find the sample mean is within 3 IQ points. So within 3 IQ points, which means the maximum error is 3 IQ points. So we will say E here is equal to 3. So the maximum error is 3. So all of the error should be within 3. So that's our E value. And then we also get the mu, get the sigma is 15. Because here we assume sigma is equal to 15. So the remaining part is not hard. We only need to plug into the formula to get to the end. But you remember, we always round up. Even though this is 96.04, we still need to round up to get 97. So you see, we use the critical value again. So if you can memorize several important critical values, something like Z sub 0.025 is 1.96, Z sub 0.05 is 1.645. Okay, that will be helpful if you can memorize this. Not always need to check the table to get to the critical value. Let's make sure you memorize the correct number. So this is for number 22, it's 97. You will find the corresponding area. You will find the corresponding formula for this sample size. This one is the sample size for the confidence interval of mean value. That's the confidence interval mean value. So you should find the related formula for your sample size. They have different sample size formulas. So next one, number 23. Number 23, we are talking about the hypothesis test again, the hypothesis test. In part A, we need to list what is none, what is alternative, and also specify it's the left tail test, right tail test, or the two tail test. So that's about the hypothesis test. Go back to check the plane. So here, company claims mean weight of the packets is 14 ounces. So this is the claim we have. And we know this claim is about the mean. So this will be the hypothesis test of our mu, right? Because the claim is about me, then we're gonna know this is the hypothesis test about mu. If a claim is about the proportion, we have a claim, we have a percentile or proportion in our claim, then that one is the hypothesis test of the proportion. This time we talk about mu. Mu is 14, so mu is equal to 14. So this is the original claim. This is the original claim. Let's check. We have the mu is equal to 14. First one, we have this, right? We transfer our sentence. We transfer our claim into the expression. It's mu is equal to 14. So next step, we should tell ourselves it's the none or the alternative. It's the none or the alternative. And we realize it's an equal sign in the middle. It's an equal sign in the middle. So this one will be our non-hypothesis, right? So if we already know the none, we could use the same notation, same value to list our alternative. But the only problem is what sign in the middle. What sign? It's greater than, less than, or not equal to. Here, from the original question, we do not have any words tells us the direction. It's like the greater than, less than, at least, at most. We do not have this kind of words, which means we do not know the direction. So we will pick not equal to as our alternative because we do not know the direction. So we should do both sides. So it's a two-tailed test. So when you have the two-tailed test, I prefer you write two-tailed next to your alternative to remind yourself. Okay? Next step, we're gonna use the original value we have here. We have the original value here. Why I should list the original data? Because we're gonna use this data to find what is the mean value and what is the standard deviation. Because when we do the test, we're gonna use these values, right? So from this one, you should find the mean value and the standard deviation. Make sure you'll go back to check the formula. How can we get the standard deviation? You have two formulas, right? One is easy to understand. Another one is easy to calculate. So make sure you pick the one to calculate, easy to calculate to get these two statistics. And when you list these two statistics, you realize you only know the information about the sample standard deviation, which means sigma is still unknown for this case. So we're gonna use the t-test. We're gonna use the t-test. So we're gonna pick the formula for t-test. So next step, we should find the t-test statistic value. So this is the formula. We have the x bar from your sample, from your original data, right? And the second value is the mu. How can we always find the mu? We go to check the claim or the hypothesis test. You know, this is the value. This is the assumption. Mu is equal to 14. So 14 is the mu value in our formula. The remaining part we are going to plug into the formula, and we will find the test statistics t. Test statistic t. But when we use this t to check the t-table, most of the time, we actually cannot find the exactly p-value. We cannot find the exactly p-value because we only can find the range because the t-value is just a part of the t-table is just part of the t-table. So we cannot find all of the values. So here we only can find the range of the p-value. So from your table, maybe you can find the area one tail is 0.1, but just like I said, we are doing the two-tailed test. You should use the area from one tail times 2 to get the area for two tails. So here, we will get the range greater than 0.2. P-value is greater 0.2. Okay, so we could use this one. This is the p-value method. P-value method to get the p-value, then compared to the alpha value. Alpha here is the significance level set. It didn't give you the alpha value, which means we should pick the 0.05 as our alpha value, right? That's the default one. We treat that one as the default one. So we're going to use 0.05. We know the p-value is greater than 0.2. So this one is not less than or equal to 0.05. So we fail to reject. P-value only when p-value is less than or equal to 0.05, we could reject. So this time it's not a case, it's greater than 0.5. Again, please remember the rule. P-value is low, then none must go. So here, this is not low enough, fail to reject. So this one called the p-value method. Of course, we could also use the critical. We could always use the critical value method to do the hypothesis test because the critical value method is also is equivalent to the p-value method. So we could check the t-table by using the half alpha. Why here I should use half alpha? Because it's the two-tailed test. So when we talk about alpha, we should use two-tailed. So we need to divide it by 2 for the alpha. And we also need to use the degrees of freedom to get this is the critical value. This is the critical value t. So if we have the test statistic t and the critical value t, we could use these two values to get the conclusion by using this rule. If test statistic t is greater than the critical, we reject, but this is not the case, right? The absolute value of test statistic is less than the absolute value of the critical value. Then we will say fail to reject. If this one is less than this one, which means this one does not fall in the reject region. So we will say fail to. Again, you could always use p-value method and the critical value method. These two methods are equivalent to each other. Oh, sorry, I find this one has the significance level at the last. So it's still the same. It's so here the conclusion should be not less than 0.01. Okay, it's not less than 0.01. So the alpha is 0.01. So here it's greater than 0.2, so it's not less than 0.01. Here I use the correct one. Alpha is 0.01, so half alpha is 0.005. That's how I get the half alpha, because alpha is equal to 0.01. So I didn't see this sentence. So if you cannot see this one, then you will choose alpha as 0.05. If you have the specific significance level, just use the significance level. So the last one will be number 25. It's still about a hypothesis, but this time it's a hypothesis test of the proportion. So last question asks you to use the critical value method. So let's start with the first step. We need to find the claim. So the claim said the proportion. So it's a claim with the proportion, which means we will doing the test about the P. And here is greater, more than 0.25. So we will have our first claim is P is greater than 0.25, right? We translate the claim into the expression. P is greater than 0.25. So we will know this is alternative because here we have the sign greater than, not equal to. So this is our alternative. Of course, we could you get the corresponding non-hypothesis based on this notation P, based on this value. But the only difference is here, the sign in the middle is the equal sign. And we also need to tell ourselves this is the right-tailed test. It's the one tail in the right tail. Because here, the alternative tells us it's greater than, okay? So I will also list the information. The P hat, we know from the question, we know. It's from the sample, so the P hat is 0.330%. And we also have the alpha value, alpha equal to 0.05. So the next step, we're gonna find what's the test statistic, right? So make sure you know this is the correct answer, or correct formula to get the Z. So here, the first value is the P hat, point estimate. And the second value, P. Can we know the value of the population P? Yes, we get it from our assumption. Okay, assumption says P is equal to 0.2. So we're going to use that value. But make sure when you check the denominator, it's not the P hat, Q hat. So don't make that mistake. It's the P and the Q. It's the P times Q, not P hat, Q hat. Some students will think that one is P hat, Q hat. When we do the confidence interval, there is a P hat, Q hat. But here, it's the P and the Q. So which means, in this case, it's 0.25 times 0.7. So the remaining parts, we only need to find the Z value. That's the test statistic Z. The question asks you to use the critical value method. So we're going to find what is the critical value. Here, the critical value, we just use the Z sub alpha. Why we do not use the Z sub half alpha? Because remember, when we write the hypothesis, we already know this one is the right tail test, which means it's the one tailed test. So it's not necessary to divide it by 2 when we find the critical value, right? When we check the critical value, it's just Z sub alpha. It's not Z sub half alpha. So here it's just the Z 0.05. That's the Z sub alpha. Because it's the one tail test. If it's two tail test, then we need to find the Z sub half alpha. And this is another special one, right? Z sub 0.05, 1.645. And we know the test statistic has greater absolute value. Test statistic has greater absolute value than the critical value. So our conclusion will be reject none, will be reject our none, which means this Z fall in the rejection region, more extreme than the critical value. So more extreme than the critical value fall in the rejection region. Of course, we say we could always use the p-value method because p-value method is equivalent to critical value method. So here, if we use critical value, if we use p-value, we're going to use this Z, right, to check the area. And this 0.9989 is the area directly from your table. But remember, we are doing the right tail test. We are actually interested in the right tail. So we should use the total area minus the area cumulative to the right side to get to this area. And we realize this area is very small. This probability, p-value, is less than the 0.05. So the p-value is low, the none must go. We reject it. Okay, that's all for the practice final exam. I will say again, make sure before you check my solution, make sure you could do it by yourself. I will post to the solution pages maybe the week after the Thanksgiving. I will also post all my solution to the content. Okay, but before you check my solution, you should do the practice final exam by yourself. Okay, first time you're gonna do it by yourself. And I suggest you could do the practice final exam at least 3 times. Okay, and don't forget to do the online evaluation. After the Thanksgiving, you are supposed to do the practice final exam several times. So that time we will hold an online meeting. After Thanksgiving, we only have the online meeting, Zoom meeting. We are not have the face-to-face section. Okay, we do not have the face-to-face section. We only have the Zoom meeting. During that meeting, you could ask any questions. Any questions about the course, any questions about the practice final exam. Okay, because by that time, you are supposed to finish the practice final exam. All right.